Okay, so we're going to talk a little bit about the word problems at the end of Module 4. Now, obviously, I cannot do the actual word problems that are on the test, but we can talk about what the word problems mean, and I can give you some background information on how you would go about answering them, the type of things that in general, we would use to answer those questions. So the first question talks about a meteorologist, and it says something about you can create your own function to describe how to find the x-intercepts and how to construct a rough graph of a function to predict when the function is going to be equal to 0. That's just a generalization of what that statement says. So basically, you're not actually expected to do a math problem here. You can, if you want to, make an equation, but you don't need to. All you're expected to do is explain, and you should be using sentences. I'm not going to. I'm just going to make some bullets here so you have a general idea, and then you can write this information in your own words. But how do we find the x-intercepts of a function? Well, we set the function equal to 0. Okay, and then after we set the function equal to 0, then we're going to use our tools and our skills that we know to find the x-intercepts. So what methods do we have to find x-intercepts? Well, we use the rational root theorem. We use Descartes' rule of signs. Once we use those things, often we use synthetic division. Once we've divided out some zeros, then a lot of times we use factoring. So these are the ways that we find our x-intercepts, and then we solve for x. Okay, so what else would we do to construct a rough graph of the function once we have the x-intercepts? We would also find the y-intercepts. And we do that by making x equal to 0 and solve for y. Okay, and then the last thing that I would have in a rough sketch that's also important, I would want to make sure I know what the end behavior does. Okay, and how do we decide end behavior? We look at the two ends, and we decide if they're going to go up on both sides, down on both sides, okay, or we decide if they're going to go up on the left, down on the right, okay, or we decide, if they're going to do the opposite of that. Okay, and in the last question, I'm going to go ahead and go over that as well, just a review of how to find end behavior. But that is, in general, what you're writing out here as you're explaining to me in order what you could do to do a rough sketch. Okay, so once I did all this, then I would put all the information on graph, all this info that I found on graph, and then carefully sketch the curve. And we know it's not going to be perfect. Okay, but that's an overall what we would do, and you would you could explain this out in your own words. All right, then the next question, find the turning point. So this is a different question from the one that you have on your test, but it's just the same idea. How do you find the turning point of a cubic function? Well, remember that if we had a quadratic function, y equals x minus 2 squared plus 4, the vertex would be the h comma k, 2 comma 4. So we do the same thing here. It's always whatever this number is and whatever that number is, as long as this is a minus sign, or basically the opposite of this and that. So this one's turning point would be 5 comma 8. Okay, if we had something like x plus 3 minus 5, remember it's the opposite of this, oh cubed, the opposite of this, and then this one like it is. So this would be negative 3, negative 5. If we had y equals x minus 4 cubed plus 11, that would be 4, 11. And if we had x plus 8 cubed minus 13, that would be the opposite of this, negative 8 comma, and then this guy as he is, negative 13. And that's just pretty much it for those. Okay, is it possible for the average rate of change to be 0 for a function, and for a function to also have a turning point? So that is the question that is posed there. They gave you a whole bunch of two people and they were arguing, and that's fine. But normally when we think about a function having an average rate of change of 0, we're thinking about the idea that the function is flat. So from here to here, it has an average rate of change of 0 because it is a flat. It's a horizontal line. If I tried to find the slope, it would give me whatever number this is. Say this was 5. Okay, it would give me 5 minus 5 over, oops, this should have just been regular 2. 2 minus negative 2 would give me 0 over 4 is 0, but we know all horizontal lines have a slope of 0 anyway, so we wouldn't even need to do that. But that's what we think of when we think of something having a rate of change of 0. However, is it possible to not be a flat line and still have a rate of change of 0? Well, it is. Okay, we could have a function that's a parabola. Excuse my ugly parabola here. Okay, and so if this value and this value are the same, say these are both 3, okay, then if I were to do the rate of change or the slope formula between the point negative 2, 3 and 2, 3, well, what happens? We would get 3 minus 3 over 2 minus negative 2, and that is 0 over 4. Okay, and so 0 divided by 4 equals 0. So the question is, can it go through a turning point? Well, it went up, it stopped, and then it came back down. So yes, it went through a turning point right here. So it goes through a turning point, but it also does have a average rate of change of 0. So is it possible? Yes, it is possible, but the only way it's possible is if it is a parabola and the y values must be the same for both points. So in this case, the points we were looking at were negative 2 and 2, and their y values are both 3. Okay, and then the last question, how do you graph a polynomial function without using technology. That's basically what that says. There's a whole bunch of information there. And we did a video like this a little while ago, so I'm not going to redo that whole video because it was a little bit lengthy. But whatever function you're given, and I'm just going to pick one for now. I'm not going to do the whole thing. I don't even know if this is even factorable, so we're not even going to try to do that. But what you would do is you would go through all those rules that we did before. You do your rational root theorem. You do your Descartes rule of signs. You would do your long division, or not your long division, synthetic division if you need to. Find one that works. Okay, then you could do your factoring. Okay, and remember with these are like optional. If you just want to plug numbers in and find one that works, that's fine. Plug numbers in, divide it out, that's fine. So what I would do for this before we, before you do the problem is just go back and watch the other video about finding the zeros. Okay, and then so rewatch that one. And then the only other thing you would want when you are graphing without using technology is you would want to find the y-intercept. So to find the y-intercept, I would make x equal to 0. So I'll just use this problem for an example. 0 cubed plus 8 times 0 squared plus 5 times 0 plus 2 gives us 0 plus 0 plus 0, just 2. That's messy. Okay, so our y-intercept is a point 0, 2. And then you need to check for the end behavior to see what the end behavior of the function does. Behavior, I-O-R. Okay, so in this case, I always just look at the first term. It's x cubed. There's a 1 in front of it that's hiding. The cubed means it goes in different directions. And the 1 being positive means that it goes up from left to right. So it would look like this on this side and this on that side, and then whatever the function does in the middle. I don't know yet because you'd have to, and we know it goes through 0, 2 somewhere. And then you would have your zeros from this part that you would mark in there and do what you needed to do with here. Okay. Like I said, for this part, you can go back and watch the other video. Okay. And again, you can just start by plugging numbers in to find one that works, and then divide out using synthetic division, and then factor, and then solve for each x. And then if you have any other questions, feel free to contact me. I'll be happy to answer them for you. Just make sure you answer your questions in complete sentences. And that's pretty much it.